Right, question 9, June 2012, starts off with a trapezium rule. That's the trapezium rule, tells you that you need 5 ordinates and 4 strips, so you set up your 5 ordinates and 4 strips. So you just keep going down your Y's until you get to number 4, then you've got 1, 2, 3, 4, 5 ordinates. The numbers that you start with is the smallest number from there, and the biggest number goes there from there, so that's between 0 and 1. And you can see that that will just go up in quarters, like so. So all you have to do now is substitute those numbers into x for each one. So the first one, 0 squared plus 1 is 1, 10 to the power of what is 1, so that will be 0. You can check it in your calculator if you need to. And then the other ones, you're going to have to use your calculator. Use your log button for base 10. And then just stick in what you need. So log, and then we're going to have a fraction, and that's going to be a quarter squared plus 1, close your bracket, and then you're going to get that number there, which is 0.02632. And make sure that you put a lot of decimal points down, because you need to round it to 3 significant figures and you don't want to do it prematurely. The next one, you have to change that to a half, and it's easy just to replay it and do it that way. So you get 0.09691, and then we're going to replay it again, and we're going to put 3/4 in it this time, and we'll get 0.19382, and then the last one we're going to put a 1 in there, so that'll be 1 squared, which is 1, and the answer there is 0.30102. Now the formula for the trapezium rule is h over 2, the first one plus the last one, which is the first one there plus the last one, plus 2 lots of the ones in the middle, which is y1, y2, y3. Like so. And then all you have to do is stick that in your calculator. So h is the height of the trapezium, which is the difference between these two numbers here. So that's a quarter divided by 2, which is an eighth. That plus that is just 0.30102, plus 2 lots of, and then I'm going to add those up in the calculator to make it easier. That's 0.02632 plus 0.09691 plus 0.19382. Don't need a bracket because I just added those up, which is 0.31705. And then if you just stick it all in your calculator, you can get the answer. So we've already got those things added together. I need to times those by 2. I need to add 0.030102. And then times and by a quarter divided by 2 is an 8, so that's just the same as dividing by 8. And the answer to 3 significant figures is 0.117. And that's all they're after for that. Question B. You've got a graph which is 2 log 10x, and you want to transform it into y equals 1 plus 2 log to the base 10 of x. Well, that graph there is the same as that graph there. The only difference is that it's got a plus 1. So that means it's just moved up 1 in the y direction. So it doesn't move in the x, and it moves up 1 in the y. Question C, part 1, is show that log to the base 10 of 10x squared is equal to 1 plus 2 log to the base 10 of x. These two things have previously been multiplied together. When you get two things multiplied together on logs, they were originally added together. So that's log to the base 10 of 10 plus log to the base 10 of x squared is equal to that. Log to the base 10 of 10 is 1, and then that's log to the base 10 of x. That 2 goes to the front, which is there, and that is equal to 1 plus 2 log to the base 10 of x. Just by knowing the plus rule and the times rule, and by knowing that the 2 goes from there to there. Question part 2 tells you to show that that graph is a translation. So we've got the graph which is y equals 2 log to the base 10 of x, and we've got y equals 1 plus 2 log to the base 10 of x. Well, we know that is the same as that, and we know that that is the same as that, which is that. So what you need to do is compare those two things. Now, to get this in the form of something squared to match that, So to get from that to that to match that, you've got to go back to there. Now if you stick an x in and square it, you'll get x squared, which is fine. But if you stick a 10 in there and square it, you get 100. So what you will have to do is square root that, which means that it's a stretch in the x-axis with a scale factor of 1 over root 10. And then the final answer, final question, is question number 3. Question number 3, we've got a curve which is y equals 1 plus 2 log to the base 10 of x. We've got another curve which is y equals log to the base 10 of x squared plus 1. Well, we know that 1 plus 2 log to the base 10 of x is therefore equal to log to the base 10 of x squared plus 1. We also know that this is the same as log to the base 10 of 10x squared from the previous part, which is the same as that, which means that that is equal to that, which means that 9x squared is equal to 1, which means x squared is equal to a ninth, which means x is equal to a third. Plus or minus a third, but the question tells you that it's a positive value, so it's a third, which means that y equals, and all you've got to do is substitute that back into one of these things over here, so I'm just going to use that one. So that's log to the base 10 of x squared, so I need to square that, which is a ninth, plus 1. Now that is the same as that. And then it tells you to find the gradient. Now the gradient is difference in y's divided by the difference in x's between that and the point of origin. So I'll call that gradient. So that means that the difference in y's is that, take away the y value of the origin, which is that. The x value is a third, take away the x value of the origin is that, which is log to the base 10 of 10 over 9 divided by 1 over 3, which is the same as 3 log 10 over 9, which is the same as log to the base 10 of 10 over 9 cubed. And you've got to keep going until you've just got a fraction, which means that we have 1000 over 729. Done.